Today we will discuss some of the data and anomaly detection features provided by the TimePictra 11 software in conjunction with the BlueSky GNSS firewall. This is the BlueSky GNSS firewall. It protects downstream systems from GNSS spoofing or jamming attacks. GNSS signals are inherently fragile signals that are capable of being jammed and/or spoofed. In an effort to mitigate the jamming and spoofing possibilities on critical timing systems, these systems and the signals being received by the systems are carefully surveyed. The surveillance of these signals allows for added visibility in the data that is being passed through these signals, which in turn increases the level of security for the critical timing systems that rely on GNSS signals. Fortunately, microchip technology has developed both software and hardware that allow for advanced surveillance into received GNSS signals. The software solution is called TimePictra 11 and is capable of monitoring and comparing data collected by systems deployed across the globe. When the software is paired with the proper hardware, such as the BlueSky GNSS firewall, many existing GNSS timing-based systems that have previously been vulnerable to attacks are instantly granted Level 5 security. This means that when paired together, TimePictra 11 and the BlueSky GNSS firewall are able to detect anomalies around the world in real time while performing advanced analysis of live sky signals. Now let's take a look at the software TimePictra 11. This instance of TimePictra 11 already has several firewalls that have been deployed across the world integrated into it, as can be seen on the list on the left-hand side of the screen. By selecting topology, the view of the firewall locations can be seen on a map. Selecting Performance and then selecting BlueSky shows a list of available BlueSky GNSS firewalls in the window below. From there, the firewalls can be selected. In this example, let's select Boulder and then select Next. And now we have access to plot many different data points that have been received by the firewall. First, let's take a look into the visibility of timing anomalies. Although GNSS is widely known for its use in navigation, it is completely dependent on timing accuracy. In an effort to determine if a GNSS signal is performing well, measurement of the phase difference between the expected versus received phase is analysed. Under normal conditions, the phase offset should be in the plus to minus 50 nanosecond range. Anomalies in timing can be gradual or sudden and can be quite complex. This small range in tolerable phase offset allows for detection of timing anomalies, one of the most important techniques for protecting against GNSS attacks. When not detected, this can cause serious errors and confusion in critical downstream systems that rely on a valid GNSS signal. As can be seen by the plot on screen, the data that's being received by this specific firewall falls well within the range of -50 to +50 nanoseconds. Because of this, no suspicious activity involving the phase time deviation is suspected to be occurring in the GNSS signal being received by this firewall. Now let's take a look at what a spoofing attack might look like in the phase time difference. The phase time difference starts at 0, rapidly spikes up to 150 nanoseconds, and then goes back down to 0. Again, the value spikes up exceeding 150 nanoseconds, and then goes back down to 0. These rapid spikes and extreme changes in phase time difference indicate that something is occurring within the system. It could be jamming, spoofing, or a bad connection. When this is detected, the firewall and TimePictra will alert the user that anomalous conditions have occurred. Next, let's take a look into the visibility of position anomalies. In critical infrastructure applications, an antenna receiving GNSS signal is typically in a fixed location, ideally in a known and surveyed position with a clear view of the sky. The position and the location of the antenna is essential for accurate timing performance. Offset in the position of the antenna can cause degraded timing performance, essentially resulting in the loss of satellite tracking. The plot on screen shows the position deviation versus time being received by the firewall. Some deviation is suspected, and it can be seen that the blue line is around the range of 10 to 15 meters, which is typical and well below the red line threshold of 30 meters. If the system exceeded the threshold of 30 meters, it would alarm and alert the users. Now let's take a look at what an anomaly in the position deviation would look like. As you can see, the position deviation starts at slightly under 10 meters, which is typical, exceeds past 40 meters, back down to 10 meters, back up to 40 meters, and then back down to about 10 meters. Every time that this line crosses that red threshold line, the user is going to be alerted that an anomaly has been detected in the system. Finally, let's take a look into the visibility of spoofing. Although the signal has been manipulated and is no longer valid, spoofing attacks can be difficult to detect since there is still a GNSS signal. Spoofing is an ever-ongoing and evolving threat that requires a defense system that can be upgraded to meet new and emerging threats. Satellites coming into view or going out of view very rapidly is one sign that spoofing could be occurring. As can be seen in the plot on screen, the number of tracked satellites being received by the BlueSky GNSS firewall is within the typical range of 7 to 10 satellites. The red line at the bottom of the plot is the threshold of satellites that are required to be connected for a valid signal. This threshold is set to 4, and the BlueSky firewall is receiving more than 4 satellites continuously. It's also important to note that the number of satellites does not rapidly change, and this data looks to be valid data. Let's take a look at what an anomalous situation involving the tracked satellite count might look like. The tracked satellite count is constant at 6, dips down to 5, back up to 6, down to 4, and eventually down to 0 satellites detected relatively rapidly. This indicates that something is likely going on with the system. An anomaly has been detected, and the system administrator would be alerted. In conclusion, security is the most important requirement for critical infrastructure operations, and this is the focus of TimePictra and the BlueSky GNSS firewall. There are many different aspects in the GNSS signal that can be interrogated by the firewall and TimePictra. This analysis provides information as to if the problem detected by the system is specific to the location or affecting a larger geographical area. The added visibility from TimePictra and the BlueSky GNSS firewall allows operators to take a quick and cost-effective action to protect the critical systems. To learn more about the BlueSky GNSS firewall, TimePictra 11, or our other timing anomaly detection solutions, please visit microchip.com.